Okay, today we're going to go over the Chapter 2 review and show you the key. You have a copy of this on Schoology. So if you don't know how to do the review, because you're giving a blank one to work through, we'll go over how to do it. The test is going to be practically identical to the review, except for the data sets. Set 1 and set 2 will be different numbers. So with the review, you have data set 1. All the numbers are jumbled up. First thing you need to do is rank order them. That's number 1. Be very careful that you include all the numbers. First count them. There's 35 of them. All right? So you got to make sure that you have 35 rank ordered. Otherwise, your frequency table will be wrong. All right. So now it wants you to identify the min, which is 1, identify the max, which is 17, and they want you to calculate the range. So that's max minus min. So the range is 16. We want to set up 5 classes or intervals. To do this, you take the range and you divide by the number of classes and you get 3.1. You always round up to get the size of your interval or class. So 3.1, round up to the nearest integer, that is 4. So when we make our chart, we're going to start with the min, which is 1, and then we add 4 to it, 5, add 4, 9, add 4, 13, add 4, 17. Now, the upper limit of your class is always going to be 1 less than the lower limit of the next class. So this is 4, 8, 12, 16. All right. Then you add 4. That's what you get. That's why you get 20. So this you could do 4 too. 4, 8, 12, 16, 20. So you look at your data between 1 and 4 and you count how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The frequency of the first class is 11. You do that for every class. And I got 11, 10, 7, 6, and 1. You add them all up, the frequency, you should get 35, which is the number of elements in the data set. Now the midpoint is just the lower limit plus the upper limit divided by 2. So 5 divided by 2 is 2.5. And you could do that for all of them. You could do the average of the 2, but you notice they're 2 apart. They're 4 apart, just like the intervals. So you just add 4. 2.5 plus 4 is 6.5. Plus 4, 10.5. Plus 4, 14.5. Plus 4, 18.5. Now the class limits, or the boundaries, you go, the first one, the intervals are 1 and 4, so you go less 0.5, so that's 1 minus 0.5 is 0.5, and then plus 0.5, 4.5. Then the start of the next boundary is the same, and there's 4, 4, 4, 4 between them all, and those are all your boundaries. So it's 4.5 plus 4, 8.5. 8.5 plus 4, 12.5. 12.5 plus 4, 16.5. And notice it's always 0.5 more than the upper boundary. Relative frequency is the frequency divided by the total. So 11 divided by 35, rounded to 2 decimals, is 0.31. You do that for every single one. If you add up all the relative frequencies, you have to get 1. Cumulative frequencies, you add the first category, it's 11. Then to it, you add the next category. So 11 plus 10 is 21. Plus 7, 28. Plus 6, 34. Plus 1, 35. Notice the total frequency is 35. If you don't get 35, you did something wrong. And the same thing, the cumulative relative frequency is adding up all the frequencies. So the first one was 0.31 plus 0.29, which is 0.6, plus 2, 0.2, 0.8, plus 1.7, 0.17, is 0.97, plus 0.03, 1. This will always add up to 1. Now we're going to do some graphs. All right. So this is a frequency histogram, or it's a bar graph, based on class limits. So put all your class limits down on the bottom. All your bars should touch, because remember, the first class's upper boundary is the same as the second class's lower boundary, so they touch. First one has a frequency of 11, second one has a frequency of 10, 7, 6, 1, and just draw your bars the best you can. See, mine are not perfect, so yours don't need to be perfect. Make sure you label your axes. This is frequency, and down here are class limits. Do you need these tick marks in between? No, you don't. I just did it to try to make things look even. Next one is a frequency poly, which is a line plot using midpoints. So put all your midpoints on the bottom, then put your frequencies, 11, 10, 7, 6, 1, and connect them with a line. Don't forget to label your axes. The next graph is an ogive based on midpoints. So put all your midpoints at the bottom. And this is cumulative frequency. So it goes 11, 21, 28, 34, 35. It ends up with 35. I'm not worried about starting at 0. All right. The same thing with this one. I'm not worried about starting at 0 and ending at 0 like the book does. All right, the next is a stem and leaf. This word left is supposed to be leaf. Plot of the data. We only have 1 places and 10s places. So you may not have the same for the test, but over here are the 10s places, and then you have all the leaves. So here's my key. The key, let's say if I was going to plot 17 in stem and leaf, the 10s places would be a 1, and the leaf, which is the 1s place, would be the 7. So I just used my rank ordered data, and I did 0 is my 10 place, and then all my 1s places. 1, 0, so that's 10, 10, 11, 12, 12, 13, 14, 14, 15, 16, 16, 17. Now you can use your rank ordered for the next one. This is you draw a dot plot of the data. So you're going to do a number line between your min and your max, 1 through 17. Put a tick mark for every single data point, and then put a dot with how many times that data point occurred. Now notice this one, 6, is the most. 6. So that's mode. Now the median, we have 35 points. So 35 divided by 2 is 17.5. That means the 18th point is your median. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That right there is your median. 6 is also your median. It's your mode and median. All right, we're going to do a pie chart. This is going to have to do the best you can with your art ability and guesstimating the degrees. Now, we're going to use all the classes 1, 2, 3, 4, 5 are going to be plotted in the circle in your pie chart. We're going to use relatively frequency. So to find how many degrees this amount here is going to be your relative frequency times 360 degrees. So when you do the math, you get all these degrees, and then you draw the best piece of pie with 110 degrees, 111.6 degrees, and that this represents your data in class 1. Data in class 2, data in class 3, data in class 4. Notice this slice of pie is only 10 degrees. Class, should be another S there, class 5. All right, now we're going to draw a Pareto chart. Pareto chart using midpoints is just largest to smallest, which for our data works out great because it's already in largest to smallest, 11, 10, 7, 6, 1. But don't count on it being in descending order for the test. So Pareto chart, you go greatest to smallest, and then down here, I guess it should not be based on midpoint, it should be based on your classes. So down here there should be class 1, class 2, class 3, class 4, and class 5. So for the test, make sure you put the classes down here. I'll make sure that this says data using classes. All right. Now here's data set 2. This is fuel economy of motorcycles. There are 21 data elements. So to do this chart, to figure out standard deviation and variance, what we're going to do is you have to put all the data, all the x's, be very careful transferring the data into the first column. All right. To get your sum, add them all up very carefully. There are 21. To get your average, you're going to do your total divided by your how many there are. Do everything to 2 decimals. So my average is 50.57. Now what we're going to do, we need to find the differences. The differences is x minus your average. In this case I did x bar. So you're going to take 53 minus 50.57 and you get all your differences. Before you get all your differences, and if you're using a calculator, go ahead and square it right away so you can get your difference squared. So 2.43 squared is 5.9. Do the same thing for every single point. If you were to add up this column, you'd come very, very close to 0. What we really need is we need the sum of the differences squared. So we're going to add up this third column, and our total of this is 1345.14. Now, for this case, the average of the population, mu, is 50.57. Now, if we look at the data like a sample, it's x bar, and it's exactly the same average. So these should be the same number. Now let's figure, considering the data, a sample data, to figure out the variance, s squared, it's going to be our sum of the differences squared divided by n minus 1. And that answer is 67.26. To get our standard deviation, we take the square root of 67.626 and we get 8.2. So this is our standard deviation of our sample. Our coefficient of variance is our sample standard deviation divided by x bar, which is the average, times 100. And we get 16.22.